Okay, 11.6 and 11.7. Oh no, it's just 11.6. We're getting into what we know as the Pythagorean theorem. We don't have to know the name of it, although it'll look familiar to a lot of you. It's this weird relationship here. If you look on the top left, I have this triangle that's denoted, that's annotated with a 6 here and an 8 here and then a 10 here. And the way that comes to relevance is this, guys. If you ever notice a right angle like this one is, there's triangles of what we call a right triangle because these two legs make a right angle. And if you ever have a right angle, there's a strange relationship that comes about. And that's to say that if you go 6 feet this way, and then another 6 feet this way at the right angle mark, then you're wondering, well, how far am I here than I am when I run over here? Well, like, how far is it? Well, obviously it's 10 steps from here to here. That's the answer. But the relationship beyond that, for much tougher problems that are the same nature, would be exactly this. It's really weird, but check this out. If I take this number 6 and I square it, 6 squared, that's 36. And then I take this number 8 and I square that, that's, 8 squared, so that's 64. Equals 36 equals 64. What do I get is these two weird numbers, but if I add them up, that looks like a times, but it's supposed to be a plus. If I add up those two answers, 36 and 64, that adds up to 100, which happens to be the same thing that I would get if I took this number times itself in the first place, if I squared it, because that's 100 too. And that's what's weird about these things, and it only works if you have a right angle going on. So, we have this. But if you ever have a relationship that's a right triangle, or in other words, a right angle and then connect the dots, we say that the two sides that make the right angle, if you square them both, take the square of both sides, like I'm doing in red here, if you add those up, you would get the same thing as you would have gotten if you had just squared the third side in the first place, the distance between them two. So you can find the distance between the two by doing this process backwards, and I'll show you what I mean. Check out this one below. On the left-hand bottom, we have 9 steps up and down, 12 steps across, and it says that it's a right angle. That's what that little boxy mark in that corner means. But these are at a right angle. What I can do is determine the distance if I ran this way, and then a dog ran this way or something weird, there's this guy running this way. How far am I over here from this guy or whatever over there? How far am I from this? This is a very far-reaching theorem, but I'm putting it in very abstract terms. Anyway, I would figure out this distance here from me to this other guy would be exactly this. I would say, well, whatever I get when I take 9 squared and 12 squared and add those together, that's what I get when I take this number times itself, or x squared, if you will. So the way we say this is essentially this. It would be 9 squared plus the other number, 12. Square that. The two right angle guys, 9 squared plus 12 squared, is equal to the diagonal side, squared. But they call it c squared, or I'll call it x squared because that was an x there. X squared. Then I just do some algebra on it. 9 squared is, of course, 81. 12 times 12 is 144. And then I say, oops, x. Well, 81 plus 144 will add up to something, and that's what my other side squared is. So then we add that up. 81 plus 144 adds up to 169 if you add that up. No, that does not. That's 5. Oh, that's 225. Sorry, I was thinking the wrong numbers. Let me erase that too. Okay. That adds up to 5. Let's just go ahead and add them up. 5, 4 and 1 is 5. And 12. Yeah, 225. Which is good, because that's a nice number to work with. Because what we're dealing with here is this. Now I have some number. I don't know what that number x is. That's what I'm trying to figure out. Is what is this number x? Not what x squared is, but what is this distance x from here to there? It's x, but what I know about it is that if I take that number times itself or square it, I get 225. So I have to think of what number times itself gives me 225. Fortunately, we have experience with this because that's just saying if x squared is 225, then x must be whatever the square root of 225 is. So that last part is just taking the square root. And that number that we're looking for is 15, by the way. 15 times 15 is 225, so 15 is the square root of 225. So the distance from me to the other guy is exactly 15 feet, or 15 steps, or whatever we were saying. 15 for my x. And so that's our general relationship, is we'll say, anytime I have this right angle stuff going on, with these two guys making a right angle, then we say exactly that. We say the A part, square it, the B part, square it, add those up, and you get yourself the square of the last one, C squared, the distance over there, or A squared plus B squared equals C squared. Now your turn, it's just a one problem, your turn, then we'll go on to the next thing. Pause this thing, try out the 5 and 12 and X deal, pause there, pause. This is me just saying pause to give you a lot of opportunities to pause that. And now pause it, and then have me check it out, and then we'll go on to the next thing. All right, next up. Now we got this going on. Check this out. What's different about these, as you'll notice, I'm not going to start with blue, let's start with a different color this time. I have the two sides that make a right angle. It's got this little box, and that means there's right angle stuff going on. So these things do make a right angle. One of those 90-degree, perfect corner type angles, whatever. So we do have the same relationship going on, but now it's like the distance between, from that story I was telling before, that part we know. I know what this distance is. That's a 5 steps or whatever. 5 yards, 5 miles, something. But I don't know one of the sides that gets me there. So we just do it backwards, and we say, well, it's still this side squared, 3 squared, plus this side squared, x squared, adds up to that slanty side squared, 5 squared. The two right angle guys add up to the other thing after you square them all. So then we just figure out what numbers we can. We'll write it down. This is a and b and c squared. 3 squared would be 9, plus x squared, of course I don't know what that is, equals 5 squared is 25. Now I have 9 plus something is 25. We can figure this out because we're good at algebra. Remember, that means just leave the x squared there and get rid of that plus 9. So to get rid of the plus 9, we'll just do a little minus 9 business, like we do. 9's are out. Now we have a positive x squared by itself equals 25. Take away 9 now. So if the wrong one is missing, you just do, it's more like a minus problem. X squared equals 16, and that means some number times itself equals 16, so then we say x must be whatever the square root of 16 is, and that's 4. Bam. Next deal up is the same kind of thing. First off, it's this one that's missing, right, the up and down one, but that won't make much difference. I will say that there's something funny coming in the answer, though, so watch out for this. Although it's stuff that you'll be prepared to handle. So here we go. We got up and down and left and right. We got the right angle guys. So we'll say x squared, up and down guys squared, plus other guy squared that makes the right angle. Right angle guys 8 squared equals the other one squared. We got that one now again. That's 14 squared. We got to run some numbers here. And so how do I get rid of that? Oh wait, let's go ahead and figure out what those things are first. X squared plus 8 squared is 64. 14 squared is 196. And then we'll minus that off there. Now we got x squared plus 64 is 196. You get that x squared by itself. Now we got to minus off the 64. This is where it gets a little bit weird. So now we have x squared equal, hey, I extended the page. X squared equals whatever that minus is 2. Let's see here. 6 minus 4 is 2. That's 3. We have 132. And this is where the problem comes in. Because now I have x squared equals 132. So then x must equal whatever the square root of 132 is. But that does not have a nice square root. So then you're stuck either just leaving it like that, or if you can simplify it, go ahead. So I'm going to go ahead and put a tentative circle on this in case I can't take any pairs out. But let's try and take some pairs out. 132 should be 11 times 12. Yeah, there you go. So this will pair out a little bit. 11, nothing goes into it. 12 is 2 times 6, or whatever you will. And it breaks down to give us 2 2s and a 3. So then, this square root, it will break down a little bit. That's the square root of 11 times 2 times 2 times 3. We've got a pair of 2's in there, so you know what to do with that, or at least I do. I'm sure most of you guys remember. Anyway, so we have, and if you don't, then, go ahead and pause this and let me explain this step in case you've forgotten, because it'll be essential to remember that. Anyway, it's from the last term, so we got a pair of 2's becomes a 2 outside, and then there's an 11 times 3 in here. That'll be like 33 inside, right? So then we'll call this equals 2 square root 33. which is, I still don't, without punching that or approximating it in a calculator, we don't know what 2 times the square root of 33 is. It's some distance, you know. You would have to just calculator it to approximate it or do some other funny algebra trick. This is good enough. We just get a square root, and either it's done and you can't do anything to it, or you can simplify it. So you always just try and bring out pairs. If nothing happens, then you're just stuck where you were before. That's pretty cool, I guess. Next, your turn. Go ahead and pause the thing, and then we'll get back into business. All right, now dig this. Don't dig this. So somebody walked in. It was Sierra. Anyway, she didn't know any better. I don't know what to tell you. So, determine the missing side. What's going on here, guys, is that we're supposed to just take an algebraic approach to this very geometric problem. And so, remembering this, maybe go ahead and write this at the top of the page somewhere. We have a squared plus b squared equals c squared like we had on the first page. And so remembering that, that's all this other a, b, and c stuff is referring to. So we just copied the junk down and understand that it's supposed to be having this geometric interpretation about distances and right angles and stuff. And so we just do it that way. Oh, a is 10, b is 24. That means I go 10 squared for a squared. Plus b squared would be 24 squared equals c squared. We don't know what c is, and we'll figure it out. Then we just do some solving. Since a is 10, I put it in the a spot. Since b is 24, I put it in the b spot. And c, I have no idea what it is, so it's just still c. So there's that, and then we'll figure it out. Let's see here, 10 squared would be 100, right? Plus 24 squared is 576 equals c squared. And then we go to town on it. Let's see here, c squared equals 100 plus 500 is 676. Believe it or not, if you square root that, I believe that puts us at c itself, since c squared is that. C is going to be the square root, of course, of 676, and I believe that is just, no, not 36, 26. Now, you don't have to have that stuff memorized, because as you'll see on the next couple of examples, of course, most of the time when you have one where you don't have the idea of well, that's just this squared, you got to factor tree it out until you get something. Because most of the time on these problems, or at least a lot of the time, you're not going to get nice answers anyway. They'll have something with a square root left over when you simplify it, and that's okay. Anyways, let's try this next one. We have a and b given again, and c is missing, so it shouldn't be too bad. A is 8, so 8 squared, plus b is 8 again, so 8 squared again equals c squared. Let's see how that goes. 8 squared is 64, and then another 64 equals c squared. 64 plus 64 is it's 128. So now we have c squared equals 128. And then we refer up here and we'll say, well, that means c must be equal to the square root of 128. And that doesn't go very well. So we tree it out, right? So we go 128, that's 2 times 64 is how we got there. It's 264. So circle the 2. 64 is 8 times 8, and those are going to split like crazy. 2, 4, 2, 2. Circle those primes. It's another 2 times 4, circle it, 2 times 2, like we do. If you have trouble with that or don't know why I circled some things and didn't circle others, go ahead and pause the video here and ask me about it, or ask somebody. And then that'll leave us with this, guys. We have c at that point is going to be equal to 2 times 2 times 2 times 2 times 2 times 2. That's 7 2's. So here we go. This is the square root of 7 2's. And we start pairing them out. There, 2 is worth 1, 2n is worth 1. 2n is worth 1. Now I got 3 2's outside. 2 times 2 times 2 is 8 outside. Square root, just a 2 left inside. So we have ourselves 8 square root 2 is our simplified form of that square root of 128, which is our c. Woo! And then finally, before I have you do a your turn again, the next deal is similar, but it's back to that same situation where it's like either A or B is missing, And so, just like you would figure, when I don't know what A is, I'll just put A, and I'll do A squared plus B squared. I know it's 21 squared equals C squared, which is 29 squared. And then you just, time stuff out. A squared is whatever. 21 times 21 happens to be 441. 29 times 29 is 841. I don't actually know where this is going, but here we go. If I have to add that, if I have a plus 441, we got to do that minus 441 thing, right? Oh, this would be real nice. Bam. I have a squared equals that minus that would be 400 even. I've got something times itself equals 400, and that is, I'll tell you what it is, it's just 20. So a equals the square root of 400, which is 20, just because I know it. But otherwise, you got to do that factor tree thing and actually figure out that it's 20 with no square root left because there's nothing on the inside. Anyway, looking good. And that brings you to the next your turn. Go and pause this thing. And then, do whatever. Have me check it out as you practice the things and everything. Alright, bringing us to the last section now. Dig this. Determine if the following side lengths form a right triangle. We have this situation, also known in construction terms, if you ever go into like union carpentry or whatever, you learn that we have the 3, 4, 5 rule, they call it. This is actually split into different terms, but it's this weird situation. Remember on the first page when we had a 6 and an 8 and a 10? Go ahead and make that a 10 for a second. You don't have to, but look at that being a 10. We had this relationship where we said, well, 6 squared is 36, 8 squared is 64, and then 10 squared is 100, so it all works out. This squared plus that squared adds up to that. And so what we have is what we call the converse, which is to say, if you ever take measurements of what you think is a right angle, and you mark out 6 feet this way, tape it off and mark it off, and then you tape out 8 feet that way and mark it off there, then you should be guaranteed that this should be the right number of feet that way by doing this a squared, b squared, c squared thing. And so, and if not, then it turns out that you don't have a right angle here, and so your cement slab might be like not poured right or something poured right. And so, we got to figure this out. And so, I'm sitting here pausing, trying to think of the best way to say this. Oh well, we'll just do it this way. What we're going to figure out is this a right triangle, which means is this angle right here actually a right angle, or does it just look like it? And the way we would say that is this. 6 squared plus 8 squared should equal 11 squared if these lengths are measured right, and that is a right angle. And so we tape it off and we try it out in the 6 and 8 and 11, and we look at the numbers and we'll see, does that actually equal 11 squared, So we go 6 squared is 36 plus 8 squared is 64 again. I'm wondering, does that equal 11 squared? And as we know, it should equal 10 squared, so it doesn't. And so all you got to do is figure out, well, 11 squared is 121. 36 plus 64 adds up to 100, so it doesn't equal 121 when you add these things up. So no, these don't add up, a squared, b squared equaling c squared, so no, this is not a right angle. Therefore, for some reason, this thing is not a right triangle. I guess we could say this is not a right angle, or maybe I measured my 6 and my 8 wrong, or my 11 wrong, who knows. But it's certainly not a right triangle as it's been measured. And so let's take us through that. Now we look at that without the picture, because they'll be presented in a little bit more abstract setting. They say, can this form a right triangle? Well, I look at this, and the two smaller ones, 8 and 15, they'll be my right angle guys to add up to the bigger guy, because of course you wouldn't have the big guy adding up to the little guys. So we'll say 8 squared plus 15 squared. I'm wondering, question mark, does that equal 17 squared? And we'll just figure out both sides and see if they're equal. 17 squared is 289. 8 squared is 64 plus 15 squared is 225. Let's try that out. That's got to be close. Let's see, 64 plus 225. That does make a 9 there, and then this is an 8. Yeah, we got 289 here on the left, which is equal to what it says it equals. So yes, this is a right triangle. At least it could form a right triangle. So we say yes. And then next one up, I'll have to make some room here. You don't have to erase all that, but I need to make some room. Maybe you do too, I don't know. Sorry if it's scrunching you. And so then 16, 24, and 30, and I'm wondering if these will work. Probably not, because the first one did, and I'm only doing 2, but let's see. I haven't worked this one out, but I did look it up in the book, because it's one of those book examples, you know. So it's pretty much guaranteed to not work out. Let's see what the numbers run out to be anyway. 16 squared is, I don't remember 16 squared. Huh. It's not coming to me. I guess we'll have to figure it out. Huh. Oh well. 6 times 6 is 36. Carry that 3, it's 6, 7, 8, 9, right? And then bam. And then that's a placeholder in case you didn't know. Some people just put a 0 or nothing. 1 times 6 is 6. That's 1. Okay, so that's going to be 6, and 9 is 15. Oh yes, of course, 256. Okay, so now if 16 squared is 256, plus 24 squared is 576. And I'm wondering, does that equal 30 squared? And 30 squared is 900. Question mark, does that equal? Bad question mark, there we go. And so we just add them up and see if it equals the 900, you know. Put my little 256 under here. Not looking like it though. 6 plus 6 is 12, so it already ends in 2. No matter what it is, it ends in 2, so it's not 900. But I guess I'll go ahead and finish this. Carry that as a 13 now, and then carry this, and it's an 8. So 832, not equal to 900. So this is a no. And that's all you got to do on these. See if the A and the B add up to the C after you square them all. Kabam. And this is the last your turn. So, you know, that brings us to the end of the video. I told somebody that I would end it with a different tagline this time than I usually do. And I said it would be something different. I remember. It was Good Golly Miss Molly. Woo! I'm embarrassed for myself after saying that.